Dividing polynomials using synthetic division. Last time we talked about dividing polynomials using long division, where you set up your divisor on the outside, your dividend underneath, and then you took your first term underneath, divided it by your first term outside, and then we multiplied, and then we changed the signs to subtract. And when you subtract down, this cancels, we get 4x squared, bring down the next term, and then continue. Divide our first term by our first term outside, so we get positive 4x, then we multiply. 4x squared minus 8x. Change the signs to subtract. This cancels, we get 2x, bring down the next term, and then complete the process one more time. Divide, and then multiply, change our signs, subtract, and then we had a remainder set up over our divisor. Now I'm going to show you another method for dividing polynomials called synthetic division. So if we're using synthetic division to divide polynomials, these are the steps we want to follow. First, you need to find the zero of the divisor and place it in a box. So our divisor is x minus 2. We set that equal to 0, add 2 to the other side, so we get x equals positive 2. So we are going to set that number inside a box. Then look at step 2. It says write the coefficients of the polynomial in descending order, substituting 0 for any missing terms. So our highest exponent, our degree, is 3, then we have 2, 1, and then our constant. So we're not missing any terms from our degree down to our constant. So we don't need to substitute 0. So let's follow the rest of the directions. Write down those coefficients in order. So we only want the coefficients. So we'll start with the 1, then our positive 2, negative 6, followed by negative 9. After we do that, you want to leave a line of space underneath all those numbers we just wrote. And then draw a line, kind of like an equal sign. And then let's follow the next steps. Number 3 says bring down the first coefficient. So our first coefficient is 1. You're going to bring that straight down, past the line. Don't do anything with it. Then look at step 4. It says multiply the coefficient by the divisor and add it to the next coefficient. So let's take our 1, multiply it by our divisor in the box. 1 times 2 is 2. You write it underneath the next coefficient, and then we're going to add down. So 2 plus 2 is 4. And then number 5 says repeat steps 4 until you get through the last coefficient. So 4 times 2 is 8. And then when we add down, negative 6 plus 8 is positive 2. 2 times 2 is 4. And then when you add down, we're going to get negative 5. Now, what we're going to do with those coefficients is written out in step 6. We need to write your quotient using the remaining coefficients with degree that is 1 less than the initial polynomial. So what that means is we're going to look at our degree from the problem, which was 3. So we're going to subtract 1, and then that goes with our first coefficient, x squared. Then we're going to follow in order. We have 4x. 2 is going to be our x to the 0, or our constant, and negative 5 is our remainder, which we put over our divisor. So we have 1x squared, a positive 4x, a positive 2, minus 5 over x minus 2. And if you look back at our problem that we did in long division, the exact same problem on the page before, we got that same answer. 1x squared plus 4x plus 2 minus a 5 over x minus 2. So whether you choose to use long division or synthetic division, you will end up with the same answer when you are dividing polynomials. Let's work out another problem in synthetic division for some more practice. So we're going to start with our divisor, and we're going to set it equal to 0. So we have x equals negative 3. That number will go in the box. Then you want to write your coefficients in descending order, making sure to substitute 0 for any missing terms. So x cubed, that is our degree, our highest exponent. So when we look at our polynomial, we're actually missing an x squared term. So I just put that up there as a little note for myself. Then we have our x term and then our constant. So x squared is really the only one we're missing from our highest to our constant. So we're going to write down a 1 for the coefficient of x cubed. We're going to put a 0 for our missing x squared term, negative 10 for our x term, and then negative 24 for our constant. After that, we want to leave a line of space and then draw our equal sign, if that's what you want to call it. So then we take our very first term, and then we're just going to drop it straight down. Don't do anything to the first one. Then we take that number 1, multiply it by the box. So we get negative 3, and then we're going to add down. 0 plus negative 3 is negative 3. Multiply it by the box, gives us positive 9. Add down, so negative 10 plus 9 is negative 1. And then multiply it by what's in the box, which is a positive 3. Then when we add down, we get negative 21. So we've completed our division, and all we need to do is write our remaining polynomial after we divide. So we take that degree from the beginning, that x cubed, and then we're going to subtract 1, and then write our x terms next to our coefficients. So we get 1x squared minus 3x minus 1 is our constant, and then negative 21 over our divisor, x plus 3, for our remainder. And then this is going to be your remaining polynomial after you have divided the original problem. So I want you to go ahead, press pause, try example 2, and check back with me when you're finished. So hopefully after you completed the synthetic division, you were left with the polynomial 2x squared plus 1x plus 3. And you should have ended with a remainder of 0, which all that means is x minus 4, our divisor, is a factor of the original polynomial that we started with. Now that's helpful because we can use synthetic division to factor polynomials as well. So if we have the polynomial x cubed plus x squared minus 10x plus 8, and then we have one of our x values, we can actually use that to factor. So what we're going to do is step 1, take the given 0 of the polynomial and place it in the box. So this time, because it already says x equals negative 4, we just want to put that negative 4 into the box. Then we're going to follow our steps of synthetic division, look at our degree, which is 3, and then make sure we're not missing any terms. So we have x cubed, x squared, x to the first, and our constant. Then let's write down our coefficients. 1, 1, negative 10, and 8. Then we want to leave a space, draw our line, and complete our synthetic division. So bring the first one down, and then we'll multiply by the box, add down, multiply by the box, add down, multiply by the box, and then when you add down, we end in 0. So that just confirms and verifies that x equals negative 4 is a 0 of the function. So then we can write down our x terms with our new coefficient. So remember, take the degree 3, and then we want to subtract 1. So we get x squared, x, and then plus 2, our constant. So if we want to finish factoring our polynomial, what we need to do here is just factor it the way we know how to get the rest of the factors. So this is one of the easy ones where we have positive 1 as a coefficient of x squared. So let's just find the multiples of 2, which is just 2 and 1, that add up to negative 3, so they both need to be negative. So we have x minus 2 and then x minus 1. Now, if we want the whole factorization of the original problem, all we need to do is include the original factor that we were given. So that means we're going to go back to that x equals negative 4 and turn it into a factor. So that means getting this equation set equal to 0. So x plus 4 equals 0. Then we're going to take that. That's our third factor. So this is the factored form of our original polynomial. So let's go ahead and practice with a couple examples using synthetic division to factor the following polynomials. So since we have x equals 3, we're going to go ahead and take that 3 and put it in the box. And then we need to make sure we're not missing any terms, x cubed, x squared, x to the first, and our constant. So let's go ahead and write our coefficients. 1, 3, negative 34, and positive 48. Then we're going to go ahead and skip a line of space, draw our equal sign, and then bring down our first term. Multiply it by the box and add down. Then you multiply it by the box, and then we're going to add down. We get negative 16, multiply it by the box, negative 48. When we add down, we get a remainder of 0, which is exactly what you want. Because if you're given a 0 of the function, it should end up with the remainder of 0. So if that doesn't happen, you want to go back and double check your work to make sure you didn't make a mistake somewhere. Then we're going to take that highest exponent, reduce it down, so we get x squared plus 6x minus 16 as our constant. Then let's go ahead and finish factoring this the way that we know how. So we're going to take the factors of negative 16, which is 16 and 1, 2 and 8, 4 and 4, and then figure out what adds up to positive 6 when one of the numbers is negative and one is positive. So we need a negative 2, positive 8. So we have x minus 2 and x plus 8. So to finish writing our final answer, all we need is that factor from the beginning. So if x equals 3, that means we're going to have a factor of x minus 3 equal to 0. So that is the final factored form of our original problem. So I want you to press pause, try example 2, and check back with me when you're finished. So hopefully your final factored form, and it doesn't matter what order you put the factors in, but you should have one that says x minus 1, one that is 2x plus 1, and one that is x plus 2. So let me talk you through this one. We started with negative 2 here inside the box, and then we wrote all our coefficients, 2, 3, negative 3, negative 2. After you complete your synthetic division, we are going to have 2, negative 1, and negative 1. And then when you write your x terms in here, this is the polynomial you're left with. Now, because you have a number, a coefficient in front of your x squared that is not 1, this is the factoring where we're going to separate the middle term and turn it into 4 terms. So you take your 2, multiply it by your negative 1, and you're going to find those factors that add up to negative 1. Then you split that negative 1 into those 2 factors, split it down the middle, find the GCF from each side, your 2x and 1, and then when you divide it, you should end up with the same factor. So you're going to take one of those as one of your factors. You're going to take your GCFs as another factor, and then don't forget the 0 we gave you in the beginning. You have to turn that into a factor by setting it equal to 0, and there is your third factor. That's it for this video. We'll see you in class for more practice on synthetic division.